Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam, whether you're targeting a grade 7 or pushing for a 9. Let's get into it.
Hook. This one intersection question cost more marks in last summer's mocks than almost any other. And here's the kicker. It's easy if you know one simple trick. Imagine working perfectly through algebra and losing marks because of one tiny sign, or forgetting to write the method down. Sound familiar? Stay with me for 12 minutes and you won't let that happen again. Episode promise. Today we focus on simultaneous equations, where one equation is linear and the other is quadratic. I'll show the substitution method step by step, explain why each move earns marks, and give you a 30-second graphical sanity check you can use in the exam. One topic, deep focus. The concept. Start here. Suppose we have the pair y equals x plus 2 and y equals x squared minus x minus 6. Your job is to find the points where these two graphs intersect. The algebraic method is substitution. Because both equal y, set them equal to each other. So x plus 2 equals x squared minus x minus 6. That single line is the setup that earns your first method mark. Write it down. The examiner wants to see the substitution. Don't skip it.
Now, rearrange everything to one side so you have a standard quadratic. 0 equals x squared minus x minus 6 minus x minus 2. Combine like terms carefully. 0 equals x squared minus 2x minus 8. I always say out loud when I rearrange, collect like terms, because it helps you focus and avoid sign errors. This manipulation is the second mark, expanding and collecting terms correctly.
Next, factorise x squared minus 2x minus 8. That factors to x minus 4, x plus 2 equals 0. So x equals 4 or x equals minus 2. Those are your possible x coordinates for intersection. Each correct route will usually earn an accuracy mark. Check your specification, but typically M1 for setup, M1 for correct manipulation, and A1 for each correct value or pair where required. Write it down, don't just think it. The examiner wants to see your method. Okay, so once you have x equals 4 and x equals minus 2, what do you do next? Do you just hand them in?
Great question. Don't stop there. Substitute each x back into one of the original equations to find the matching y. Our linear equation is easiest. For x equals 4, y equals 4 plus 2 equals 6. For x equals minus 2, y equals minus 2 plus 2 equals 0. So the intersection points are 4, 6 and minus 2, 0. This substitution back is quick and it wins marks, and it's your check that your roots actually satisfy both equations.
Exam technique. Let's be explicit about marks. Typical breakdown for this kind of question is M1 for correctly substituting one expression into the other or writing them equal, M1 for correct algebraic manipulation to produce the quadratic, M1 sometimes awarded for correct factorisation or use of quadratic formula, and A1 for each correct root or final coordinate pair. So with 2 correct points, you can secure multiple accuracy marks. Even if you can't finish, write down the substitution and your manipulated quadratic. That's potentially 2 marks on the board.
Common mistakes that lose method marks. 1. Sign errors when moving terms across the equal sign. 2. Incorrect expansion or combining like terms. 3. Stopping after finding only one root. A solid habit, always rearrange to 0 on one side, and then check your factorisation by multiplying the factors back out quickly in your head. If you can't factorise, use the quadratic formula. Show the substitution of A, B and C, and you'll pick up method marks even if arithmetic gets messy. The quick win. Do this in under 30 seconds before you move on. Compute the discriminant of your quadratic after substitution. For ax squared plus bx plus c equals 0, the discriminant is b squared minus 4ac. If it's positive, you know there are 2 real intersections. 0 means 1, negative means none. It's a fast check against careless algebra. If your discriminant is negative but you found 2 real roots, something's wrong. Another 2-line check. Take each root and substitute back into the original linear equation. If the y values match the quadratic when you substitute there too, you're done. That substitution back takes 10 seconds and catches about 90% of sign and factorisation mistakes. Don't skip the check. Don't skip the check, I always say.
That sounds too easy to be true, but I'll try it. Can I practice with a quick question now?
Worked practice prompt. Try this pair now. Y equals 2x minus 1 and y equals x squared minus 5x plus 6. Pause the podcast, set them equal and solve. Expected setup, 2x minus 1 equals x squared minus 5x plus 6 gives x squared minus 7x plus 7 equals 0. You'll see the discriminant is minus 7 squared minus 4 times 1 times 7 gives 49 minus 28 equals 21. Positive but not a perfect square, so expect 2 real irrational roots and use the quadratic formula. Mark breakdown reminder. M1 for substitution, M1 for correct manipulation, M1 for applying the quadratic formula correctly, and A1 for each correct numeric root you calculate. If you get stuck, write down the formula substitution. That'll often earn method marks.
Final recap in 1 line. Set the 2 expressions equal, rearrange to make a quadratic, factorise or use the formula, then substitute back to get the y values, and always do the quick discriminant or substitution check before you hand your paper in. That's your quick win for today. If this helped, share it with a friend who's revising. You'll find more worked solutions and revision resources at jcacademyonline.co.uk. Until next time, trust the process and nail that exam.
Stay curious. Thanks, Dr. Carter. That example really clears it up.